Hey class, back one more time. This is as advanced as we can get here of a problem that I expect you to be able to do. And so here, if we look at our chemical equation, we have C8H18, which is actually octane, which is found in gasoline. And so we know gasoline's used in cars and vehicles to produce lots of energy, so we burn it. So this is a combustion reaction, and so we are going to combust octane, gasoline, in the presence of oxygen. Things need oxygen to burn. And as a result, it's going to produce carbon dioxide and water. Alright, so once again, draw a line down through the center, down through the arrow, separating the left side and the right side. And let's make a tally, make an inventory of how many of each element we're starting with and ending with. So we have carbons. Let me make that a little bigger. We got hydrogens, and we got oxygens. And so once again, same thing on the right side. Keep it in the same order. Do yourself a favor. And octane, we have 8 carbons. We have 18 hydrogens in one octane molecule, and then we have 2 oxygens. Oxygens are naturally found as in pairs. Alright, over here we have 1 carbon in the CO2. We have 2 hydrogens over here. And then this is one place where it gets a little tricky. On the right side, we have oxygen in the CO2, and then we also have oxygen in the water. So you have to say, alright, there's 2 oxygens here, O2, plus 1 oxygen here, so 2 plus 1 is 3. Alright, so my recommendation is, because oxygen is found in 2 places on the right, let's save the oxygens for the very end, very last thing that we do. So let's start here with carbons. We have 8 carbons versus 1. So if there's 1 carbon in every one of these CO2 molecules, how many of those molecules do we need to get 8 carbons? So what times 1 gives you 8? So we would need to end up with 8 carbon dioxide gas molecules. So there's 1 carbon in each one. There's 8 of them now, so 8 times 1. We now have 8 carbons. We also have more oxygens. There's 2 oxygens in each one of these. We now have 8 of them, so 8 times 2 is 16. 16 oxygens plus the 1 over here. Grand total of 17 oxygens on the right side. Carbons are balanced. Everything else is not. So let's step up here to hydrogens. We have 18 hydrogens on the left, 2 on the right. They're found in pairs here. So how many pairs of hydrogens do we need to get 18? So what times 2 is 18? 9 times 2 is 18. So we need to end up with 9 water molecules. So 9 times 2 is 18. So I'll update my inventory. But I also added more oxygens here. So I still have 8 times 2. I still have 16 oxygens here, plus 9 times 1. So 16 plus 9 is 25. Carbons are balanced. Hydrogens are balanced. Oxygens are not. On the left side, we start out with pairs of oxygens. So this is my piece of advice to you. Because this is a even number, and we end up with an odd number of oxygens over here, it's tricky. So this is like a temporary solution. So what times 2 will give you 25? 12 and a half times 2 will give you 25. So we can't end up with half of a molecule. Alright, but temporarily we can put 12 and a half here. So 12 and a half times 2 is 25. So as of right now, we need 1 of our octane molecules is going to burn, is going to combust, react with 12 and a half pairs of oxygen to make 8 carbon dioxide gas molecules and 9 water molecules. So that we have even numbers, a way that we can work around this is, let's just double the whole recipe. So instead of having 1, let's start out with 2. If we have 12 and a half and we double the recipe, we can use 25. If we have 8 of these, we double the recipe, we need 16. And if we have 9 of these waters, and we need to double the recipe, 9 times 2 is 18. And that is the answer. So 2 will react with 25 of these to make 16 of these and 18 of those. Alright, there you have it. Thanks for watching.